Close your eyes for a moment and imagine that you are no longer lying in your bed, but drifting weightlessly in an endless darkness where there is no above, no below, only a night as thin as breath and distant stars blooming like little sparks of thought within your mind. The space around you is so silent it feels almost sacred. Every small movement of your awareness seems as if it could stir the entire universe, and within that stillness, a slow line of light begins to appear, soft, faint, like a trace of memory the universe forgot to erase. You are standing at the edge of infinity, a place where every question about the cosmos, about time-space, and the very nature of existence becomes gentle, as though none of them are demanding answers anymore, but simply wanting to be heard. Tonight, for a little more than an hour, you and I will walk through that darkness together and explore the tenderest secrets of the universe. The dimensions that stretch beyond anything the human mind can imagine. The distant moons that may be hiding oceans of life. The wandering black holes, the galactic walls that span tens of billions of light years. And the stories that light itself has spent billions of years traveling just to deliver to us. You don't need to try to understand everything. Let each story drift slowly past you, like cosmic waves brushing gently against the shore of your awareness. And perhaps somewhere within those quiet spaces, you will feel the thing humanity has always sought, a small moment of connection between yourself and the vast universe that gave birth to you. Are you ready? Then let us begin from the place where everything first came into being, the earliest dimensions of reality. Let me tell you one of the softest yet most profound stories humanity has ever tried to imagine, the story of the dimensions. A story not meant to entertain, but to open within you a quiet inner space where the mind is allowed to loosen and the soul is allowed to dream. Imagine for a moment a single line, thin as a strand of thread, drifting in the dark. No up or down, no left or right. Only one direction in which existence can unfold. That is the first dimension, the world of the singular, of length and of solitude. A world that cannot embrace anything because it can only move or remain still. Then you gently place another line across it, touching the first like two breaths crossing paths. And suddenly, as if a doorway opens, a flat space appears. This is the second dimension, the world of surfaces, where movement begins to have choices. A being living in 2D would never know above or below. They would exist forever in an endless sheet of paper, flat as fate itself. But you and I, we are not 2D beings. We belong to a vaster realm, three-dimensional space, a place where things take shape, possess volume, and carry the warmth of depth, where we can turn our heads, change direction, step left or right, look up at the sky and realize we are standing inside a boundless ocean of space. But the story does not end there. For there is another reality, subtle yet powerful, woven through every moment of our lives, though we often forget it exists: time. Einstein once wrote in Relativity, the Special and General Theory, people like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. To Einstein, time is not an independent river. It is the fourth dimension interlacing with space like threads woven into cloth. Space and time merging into space-time. A vast tapestry where every thread is an event, a motion, a lifetime. And you listening to these words in a quiet room with gentle light and a slowing breath are lying on that tapestry as well, softly, silently, unnoticed. But what makes philosophy and physics so wondrous is what happens when we step beyond those familiar four dimensions. Many scientists have realized that the universe cannot be fully explained with only four. The delicate tremors of subatomic particles, the mysteries of gravity, the dark regions of the cosmos from which no light escapes, all of it. Hints that behind our three-dimensional curtain lie other chambers of reality. And from the heart of intricate equations, from the longing to unify all forces of the universe, an idea was born: string theory, and later M theory. According to string theory, every particle we know, protons, electrons, is not a dimensionless point. It is a tiny vibrating string, a rhythmic pulse of the cosmos, and each pattern of vibration is a different note of reality. But for these strings to vibrate properly, the universe needs more than 4 dimensions. It needs 10, even 11. Dimensions not just greater in number, but curled, folded, hidden away in scales so small the human eye can never perceive them. Like a sheet of paper rolled onto itself millions of times, until it becomes so tiny it seems to vanish. A physicist once said something beautifully simple. We live in a shadow of a much larger reality. We are merely the silhouette of something far more vast. So what are those dimensions? What lies there? Who lies there? Is there another version of you? Are there universes where history moved to a different rhythm? These questions, in a way, are not meant to be answered. They exist to open your mind like a door leading into stillness. Carl Jung once wrote in Memories, Dreams, Reflections, "Your vision will become clear only when you can look into your own heart." Perhaps when we gaze into the universe, we are in truth gazing into ourselves, into the vastness we carry within but rarely touch. So let your thoughts drift gently, drifting through the dimensions as a leaf passing through layers of wind. Imagine that beside you, just one cosmic vibration away, countless other realities might exist, each one a different version of the story you are living now. These dimensions do not ask us to understand them, to calculate them, or to prove them. They simply invite us to sit quietly in the night, breathe deeply, and feel humbled before a universe larger than any description. If you listen closely, you may feel as though the universe is breathing with you, slow, warm, and distant. And in that shared breath, you realize from the lonely line of 1D to the flat plane of 2D to the spacious world of 3D and the flowing river of 4D, everything is a staircase inviting us to rise, to see more deeply, and to open more fully to the immensity of existence. Perhaps we will never witness the 10th dimension, but sometimes simply knowing that it may exist is enough to quiet the mind, as if we were looking into a night sky with no end. And tonight, as you lie down, perhaps you will feel that you are no longer small, but floating in an ocean of dimensions where every question, every worry, every longing becomes as light as stardust, dissolving gently into the tender darkness of the universe. 2. The history of space-time. Thought from philosophy to Einstein, as we close the first chapter on dimensions where fragile lines opened into countless possible worlds, and where time revealed itself as the quiet current woven into the fabric of existence. You may feel something subtle unfolding in your mind, as though another door has trembled softly, a door leading back into the ancient past to the moment when human beings first asked, what is space truly? Where does time come from? And why do we live inside them at all? Let us step through that door slowly, as if walking into an old chamber filled with whispers that have never faded. Thousands of years ago, long before telescopes, long before equations, long before the brilliant cosmological models of the modern age, human beings gazed at the night sky in awe, and from that awe they began to think. Plato, with his realm of ideals, believed reality was more than what the eyes could perceive. Aristotle tried to define motion causality and the magnitude of the cosmos. But perhaps the one who planted the deepest seed for the question of space-time was Heraclitus, who wrote in fragments, "Everything flows," a simple sentence, yet a faint premonition of the universe's inherent motion. Time is a flow, space is a flow, and human beings are but tiny sparks drifting within that ceaseless movement. Centuries later, Kant added another layer to the unfolding thought. In Critique of Pure Reason, he wrote, "Space and time are the frameworks within which the mind is constrained to construct its experience of reality. Space and time are not objects, not independent realities. Hey are mental structures, templates through which we understand the world." Dear listener, can you feel how with each of these ideas we drift deeper into the very roots of how we exist time past? The ancient philosophical reflections slowly transformed into great questions for mathematicians and physicists. And then, at the dawn of the 20th century, a quiet figure emerged onto the stage of thought, carrying an idea so strange it reshaped our entire view of the world. Hermann Minkowski. He was not a philosopher, not someone enamored with metaphor, but perhaps because of that, his vision of space-time was startlingly clear. In a 1908 lecture, Minkowski declared, "Henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." From that moment onward, space alone, time alone became merely shadows. Only when they merged did a new reality appear. Space was no longer a static three-dimensional stage. Time was no longer an independent river. They intertwined like two sides of a soft ribbon, becoming space-time, an invisible fabric through which all matter, all light, all motion must pass. You might imagine space-time as a luminous net. Every step you take, every breath you draw, every star exploding on the far side of the galaxy, all of these carve faint lines across that net. Right now, as you listen to this voice, a gentle path of your existence is stretching through space-time, delicate as a trace of awareness continuing onward. A revolution born of profound simplicity. If Minkowski painted the background, then Einstein was the one who placed the final strokes upon it. In Relativity, the Special and General Theory, Einstein wrote, "Time is what the clock measures." A sentence that appears simple, but within it lies an entire rebellion. Time is not absolute. It does not flow equally for everyone. It contracts, stretches depending on motion and gravity. A person standing on Earth lives in a different rhythm of time than someone drifting in deep space. A person near a black hole experiences a different flow entirely from someone standing beneath the gentle morning sunlight on our blue world. One universe, yet each of us lives in our own stream of time, like little tributaries branching from an unseen ocean. Einstein revealed that gravity is not a force pulling things downward. It is merely space-time bending under the presence of mass. Imagine placing a heavy sphere onto a sheet. The sheet curves, and smaller marbles rolling around it do not move because they are pulled, but because they follow the natural curves of that sheet. The universe behaves in the same way. Planets orbit the sun not because they are tugged, but because they are gliding along the curved pathways of space-time. And you are living upon such a subtle curve right now. Looking back from ancient philosophers to Minkowski and Einstein, we have traveled a long journey of thought. From Plato asking about the nature of reality, from Kant defining the structure of experience, to Minkowski stitching together space-time, and Einstein animating it with curves, tremors, and gravitational waves. From abstract questions, we arrived at a model capable of describing the motion of the entire cosmos. And yet, despite how far we have come, the most fundamental questions remain. What is space? What is time, and why do we exist within them? Perhaps as Heidegger wrote in Being and Time, time is not a thing, thus nothing which is, and yet it remains constant in its passing over beings. Time is not a thing, and because it is not a thing, it seeps into all things, like the breath you inhale and exhale, shapeless, colorless, and yet the foundation of every movement within you. Space is the same, a silent backdrop supporting every moment of life. When thinking about space-time, we are easily swept away by the overwhelming vastness of the universe. But in truth, these theories are not only about galaxies, stars, or equations. They are also about you, for you are part of space-time. A tiny fold in the cosmic fabric, a delicate curve of awareness, an event the universe records with astonishing gentleness. You do not merely live inside space-time, you are a piece of it. And perhaps that is why whenever we grow calm, whenever we slow down, whenever we breathe deeply, we feel as though the universe expands a little inside us, as though space-time not only surrounds us, it echoes within us like a quiet, dark lake. Take a moment to feel the space around you, feel the distance between you and the walls. Feel time flowing just a little slower. Feel your body sinking more deeply into the place where you rest. Because we are about to step onto another path, not just the nature of space or time, but the places where humanity first touched them, the moons, the eternal shadows, the first footprints along the road of cosmic exploration. 3. Chandrayaan 3 and the human journey to the moon's southern darkness. As we close the previous chapter, where the story of space-time unfurled like a soft fabric moving gently beneath the universe's breath, perhaps you felt something strange and tender awakening within you. A connection. A thin thread weaving between pure ideas and the quiet, courageous missions humanity carries out in the darkness of space. For in the end, no matter how beautiful Einstein's equations or Kant's reflections may be, they always return to one profoundly human question. Where are we in this vast universe? And more importantly, how far do we dare to go? And so, from the contemplative landscapes of philosophy, we step softly into a different kind of story, yet one that feels astonishingly familiar. The story of Chandrayaan 3 and humanity's patient journey into the eternal shadows of the moon's south pole. A story not only about science, but about courage, about faith, and about the quiet tenderness of light reaching toward the darkest places. If you look up at the night sky right now, you will see the moon drifting like an ancient memory. Yet, no matter how many times you have seen it, there remain places where sunlight has never touched. Black valleys, deep craters hidden eternally by the moon's tilt. Places where humanity in millions of years of existence had never set foot. And it was there in that silent southern darkness that Chandrayaan-3 touched down. Like a faint exhale from all of humankind, whispered into a region so cold that even atoms barely move. Perhaps as you hear this in the stillness of night, you will feel what Rilke once wrote in letters to a young poet: "Let everything happen to you, beauty and terror, just keep going. No feeling is final." Chandrayaan-3 is exactly that, a testament to how humanity keeps moving forward even when the path ahead is swallowed by infinite shadow. The moon has no atmosphere like Earth, but it does have an exosphere, a layer of gas so thin that the slightest movement of a hand could disturb it. And Chandrayaan-3 measured its delicate fluctuations, the density of its faint gases, weak ions blown from the sun and rebounding away, tiny movements invisible to the human eye, yet movements that tell the story of the moon's formation and all it has lost. You could say that the lunar exosphere is like the final breath of a world that was once younger, once more active. Sumi. Breath Chandrayaan-3 managed to capture in its brief moment at the South Pole. Meanwhile, the ionosphere, the thin layer of charged particles hugging the surface, revealed something quietly remarkable: the moon, though silent, is not dead. It still interacts with the solar wind. It still generates faint electrical currents. It still shifts with the rhythm of lunar day and night, like a heart beating so slowly that you must listen deeply to feel it. One of the gentlest yet most striking discoveries of Chandrayaan-3 was temperature. On the moon's surface, sunlight can heat the soil to more than 60 degrees Celsius during the day. But just a few centimeters below, temperatures fall to nearly 0°, a drop so sudden it feels almost surreal. And you know that contrast is its own quiet lesson when the universe has always whispered to us: where there is light, there is always shadow. Every calm surface hides a deeper, quieter layer beneath it. Nietzsche once wrote in Thus Spoke Zarathustra, "One must still have chaos in oneself to be able to give birth to a dancing star." The moon is the same. Beneath its silence lies a chaos that once boiled and now lingers only as faint thermal echoes telling an ancient tale. During NASA's Apollo missions decades ago, we learned that the moon indeed has quakes. But it was Chandrayaan-3 that showed us that even at the South Pole in the eternal night, the moon still trembles, softly, slowly, like a long, drawn-out sigh. Moonquakes are unlike earthquakes. They do not arise from shifting plates or oceans or living worlds. They come from cold itself, from the tightening of rock as the moon surrenders its heat to darkness, a quiet expansion and contraction of a world that has been alone for billions of years. When Chandrayaan-3 recorded that tremor, I imagined it like the moment you lie awake in a silent night and hear your own heartbeat, a reminder that you are still alive. Another crucial discovery: Chandrayaan-3 found traces of sulfur, iron, titanium, calcium. These elements are not mere scientific data, they are records. Chemical journals written by a moon that once melted, once endured meteoritic bombardment, once held a faint magnetic field, once spun faster than it does now. Every element is a story, a memory. Sulfur hints of ancient volcanism. Iron, the cooling of a metallic heart. Oxygen, locked in minerals waiting for future revelation. As you listen, allow your mind to drift as though brushing the pages of an old book, with each layer of lunar soil a chapter. Each chapter a different age. These discoveries do not merely explain the past, they are foundations for the future. Because if humanity is to set foot on the moon again, to build bases, extract resources, or prepare for journeys far beyond, we must understand the South Pole. And that is why Chandrayaan-3 becomes the stepping stone toward LUPEX, the Japan-India collaborative mission, and Chandrayaan-4, which will bring lunar samples back to Earth. Perhaps one day, when you grow older, or when the next generations rise, a small light will glow at the moon's South Pole, the first human base on another world, a humble beginning for a dream immeasurably vast. Before we step into the next chapter, grant yourself a moment of quiet. Let the images that have drifted past the moon's deep shadows, its slow trembling, its ancient elements, its first robotic footprints dissolve into one another like ripples on a still lake. Let your body soften a little. Let your breath slow a little. Let your heartbeat grow gentler. For the next chapter will guide you into deeper mysteries, things buried beneath ice, beneath layers of dark rock in places where light has never arrived. When you are ready, we will continue. For now, let your mind drift like stardust. 4. The hidden ice and subsurface geology of the moon. As we leave the previous chapter where Chandrayaan-3 touched the moon's south pole like a soft pause in the music of the cosmos, perhaps you can still feel the echo of that silence, a silence thick and ancient, colder and older than anything we have ever known about the world. And yet from within that silence, another question rises light as mist vast as the universe's shadow. What waits beneath the moon's surface for us to name it? For what Chandrayaan-3 discovered was only the first doorway. Beneath that gray soil, beneath those eternal shadows, beneath temperatures hundreds of degrees below zero, lies a world humanity has only begun to touch through scientific intuition and the primal curiosity of the mind. And tonight we will descend together slowly, gently, as though walking deeper into a dream to explore hidden ice. Underground tremors, ancient volcanism, and the billions-year-long story of our oldest celestial companion. The idea that the moon could hold water ice was once unthinkable. From afar, its surface appears dry to the point of desolation. No air, water evaporating instantly, sunlight burning away every wandering molecule. But then humanity realized that some places on the moon have never seen the sun. Craters at the south and north poles, eternal pits whose angles never allow sunlight to reach them. In these places, temperatures can fall to 230 degrees Celsius, cold enough for any molecule of water to sleep undisturbed for billions of years. Measurements from Chandrayaan-1 LRO and now additional data from Chandrayaan-3 reveal that water ice may exist like faint whispers mixed with the soil or tucked a few dozen centimeters beneath the regolith. And when you think about this, you might feel something strangely tender that even in the most barren places imaginable, the universe preserves a little water, a little softness, a quiet gift for those patient enough to search. The poet Mary Oliver once wrote in Devotions, "What is it you plan to do with your one wild and precious life?" And sometimes the answer is simply to go seeking those ancient drops of water sleeping in the moon's darkness, for they may be the key to life beyond Earth or to humanity's first outpost in the future. In the previous chapter, we heard of the tremors Chandrayaan-3 recorded, but to understand them deeply, we must look at the unique nature of moonquakes. Earthquakes, because plates shift, magma flows, oceans crash against shores. But the moon, a dry, frozen, lonely world, trembles for different reasons. Perhaps because its crust contracts as temperatures plummet too quickly. Perhaps because of small meteorite impacts. Or perhaps because of tidal forces from Earth stretching the lunar surface like a taut string brushed by a passing breeze. The unusual thing is moonquakes last for tens of minutes, sometimes hours, as if the lunar surface sings a long, fading note spiraling through layers of rock, widening like ripples across a silent lake. Sartre once wrote, "In being a nothingness, man is a being haunted by the silence of the world." But sometimes it is in the world we believe to be silent that we hear the deepest sounds. The moon does not speak, but it trembles. It lets us know that beneath its stillness, it is still changing, still holding secrets in its quiet heart. Today we see the moon as a cold, lifeless world, but once it blazed with magma, the beating heart of a young celestial body. The basalt plains, we see the seas the ancients named like Mar Tranquillitatis and Mare Imbrium are not seas at all, but vast wounds flooded long ago by molten rock. Chandrayaan-3 and earlier missions hint that lunar volcanism may have persisted longer than we thought possibly, until a few 100 million years ago, not so long in geological time. This means the moon is not merely a relic of the past, but was once a vibrant dynamic being pulsing with energy. As the philosopher Alan Watts wrote in the book, "You are an aperture through which the universe is looking at and exploring itself." When we study the moon, we are not only exploring it, we are allowing the universe to explore itself through human eyes. We cannot speak of lunar geology without speaking of the moon's origin. The leading theory today is the giant impact hypothesis. Long before you or I existed, long before dinosaurs, long before Earth had oceans, a Mars-sized planet, Theia collided with the young Earth. The impact vaporized rock sent molten debris into orbit, and from that glowing ring, the moon crystallized. Think of that, the moon is not other than Earth. It is a piece of Earth, a fragment torn away, drifting outward yet circling us like a faithful memory. And if the moon is a memory, then its geology is the earliest chapter of our planet, written in stone, in ice, in fractures stretching across kilometers. Nietzsche once wrote in Human, All Too Human, in every true man a child is hidden that wants to play. Perhaps Earth is the same. And the moon is that child, a smaller self, a companion from infancy, still circling its parent in a 4-billion-year-old game of orbiting play. Over billions of years, the moon cooled, its core contracted, its crust hardened, its magma died, its transient atmosphere drifted away. But in that fading, the moon became a perfect time capsule. No wind, no water, no life to disturb its surface. Every impact, every quake, every thermal shift remains preserved. It is a place where time almost does not pass. Marcus Aurelius once wrote in Meditations, "All is ephemeral fame, and the famous as well." On the moon, those words become painfully true. Everything is temporary, and yet everything is preserved forever. Now, having walked through the moon's layers in your imagination, having seen the ice resting in shadow, heard the slow tremors of moonquakes, felt the ancient warmth of lava seas, and touched the origins of Earth through lunar dust, you may feel your mind soften, as though you have wandered through an ancient land only to return gently to your own breath. And as that breath grows slower and deeper, you will be ready for the next chapter, a chapter where we look not only at familiar moons, but at distant ones' worlds that may cradle oceans of life beneath their frozen shells. 5. Exomoons, the greatest candidates for life beyond Earth. As our journey across the moon folded to a close in the previous chapter, you may have felt a strange quietness settling through your mind, a stillness born from gazing into things that have slept for billions of years. Ice hard as glass, quakes that echo like a distant memory, ancient lava plains still holding the fading warmth of a youthful world, all of it whispering that even the places we call dead are carrying secrets that long to be heard. And as we step away from that ancient realm, we carry a gentle question with us. If life can sleep in the moon's darkness, could it also hide farther away, deeper still, in places where even the light of their own stars cannot fully reach? Let you and I drift now, drifting along the orbit of an idea once considered strange, but now increasingly convincing in modern science, that extraterrestrial life may not live on planets at all, but on their moons. For decades, humanity searched for life on exoplanets, on second Earths, on distant blue worlds. But then geophysical models, observations from Hubble and Kepler, and lessons drawn from our own solar system began to reveal something different. That life, if it exists elsewhere, may be nestled on exomoons' moons orbiting distant planets. And these moons, if large enough, could resemble Earth more closely than any exoplanet we have ever found. And as you sit here tonight listening to this voice flow slowly like warm water, imagine that somewhere out there, tens of light years away, moons are circling giant planets and star systems no human eye has ever touched. These moons are not lonely companions like ours. They may be Earth-sized. They may hold atmospheres, subsurface oceans, methane rain or water snow, purple skies or green horizons, and perhaps life. Carl Sagan once wrote in The Cosmic Connection, "Somewhere something incredible is waiting to be known." And perhaps that incredible thing may not lie on a planet at all, but on a moon. What makes exomoons such promising candidates for life is the delicate balance of energy they receive. A large moon orbiting a giant planet does not rely solely on its star. It is also warmed internally by the pull and release of tidal forces from the planet it circles. That gravitational stretch folds and unfolds the moon's crust like the slow inhalation and exhalation of a breath. This process generates heat, sometimes enough to keep a hidden ocean liquid, even when the surface above is frozen to 180 degrees Celsius. In our solar system, we already have perfect examples: Europa, with an ocean deeper than all of Earth's oceans combined; Enceladus, spraying water and organic compounds into space; Titan, whose atmosphere is thicker than Earth's; If such wonders exist a billion kilometers from the sun, what might exist in the richer environments of distant stars? As you hear this in the silence of night, let your imagination drift like a quiet vessel across the cosmic sea. Those moons may be harboring life this very moment, their signals still traveling through space, perhaps centuries away from reaching Earth. A small planet struggles to hold on to an atmosphere, but a large moon within the magnetic embrace of its parent planet can maintain an atmosphere far more easily. An atmosphere that stabilizes temperature, protects against radiation, preserves water, and keeps organic molecules intact. Imagine a vast moon orbiting a Jupiter-like planet, but within the habitable zone of a red dwarf star. You look up from the moon's surface and see a massive gas giant dominating half the sky. You hear the hidden ocean beneath the ice. You feel the wind flowing across lakes of liquid methane. On such a world, the sky might be violet or golden. The water might glow faintly under the star's dim light. And life, whether microbial or something far more evolved, could thrive there. In the Varieties of Scientific Experience, Sagan wrote, "Life is the universe knowing itself." If that is true, then each moon could be another window through which the universe reflects upon its own existence. In astrobiology, one truth stands firm: liquid water is the foundation of life as we know it. And subsurface oceans on large moons offer advantages over planetary oceans. They are stable, they endure for billions of years, they are warmed from within, and they are shielded from harsh stellar radiation. On Europa, the underground ocean is 100 kilometer deep, twice that of Earth's deepest waters. On Enceladus, the plumes erupting into space contain amino acids, the basic ingredients of life. This is no longer the romantic speculation of science fiction. This is data, observation, a gentle but powerful truth about where life may take root in the dark. As you listen, let your mind touch the idea that somewhere beneath an icy crust, perhaps 30 light years away, an ocean is gently stirring. And within that ocean, tiny organisms may be living their first moments unaware that a distant civilization has been waiting millennia to discover them. For years, we searched for life based on Earth's blueprint, and that made sense. But the universe is under no obligation to repeat Earth. If Earth is a poem, then Europa may be a haiku, Titan a somber melody, and distant exomoons poems the universe left untranslated. Nietzsche wrote in The Gay Science, "There are no facts, only interpretations. Perhaps life is not a variation of Earth. Perhaps life is 1,000 interpretations of what it means to exist." And exomoons are those interpretations, quiet, profound, patient-like dreams the universe is not yet ready to reveal. Now, having drifted through subsurface oceans, past glassy ice plains, across massive moons, glowing beneath the violet light of red dwarfs, through reflections on life that might be blooming in the dark, let your body settle a little. Let your heartbeat slow. Let your breath soften like water. 6. The Saturn system. Young rings, the hexagon storm, and 2 worlds that may harbor life as we drift away from the previous chapter where distant exomoons opened a doorway into the possibility of life quietly growing in hidden oceans. Your mind may still feel as though it is floating like a small boat resting on a still and silent sea. You have just passed through worlds of dim light where moons might become home to strange forms of life, where the universe whispers through tidal waves and invisible rhythms. And now another light begins to appear, a world so wondrous that even within our own solar system, it can quiet the human heart with its beauty and mystery. A world that wears rings like an ancient goddess spinning through darkness as if dancing an endless, slow, sacred waltz. Saturn. Saturn, the jewel of the solar system, the keeper of 3 great mysteries humanity still cannot fully explain. Let us drift into that world gently, softly, as though we were crossing the threshold of an ancient temple under moonlight. For centuries, Saturn's rings have fascinated the human imagination, but only in the modern era through the Cassini spacecraft did we learn the strange truth. Saturn's rings are young, merely 100–400 million years old. Young enough that when dinosaurs walked the Earth, the rings may not have existed at all. Young enough that in the 4.5 billion year age of the solar system, they are nothing more than a momentary shimmer. And not only young, they are vanishing. A phenomenon called ring rain, where tiny ice particles are drawn by Saturn's magnetic field into its atmosphere, dissolving like soft snow into a giant sea of gas. If you listen closely, perhaps you'll feel a strange fragility in this, as though Saturn is wearing a silk scarf that one day a gentle wind will carry away. Marcus Aurelius wrote in Meditations, "All things fade into the storied past, and everything soon passes away." Saturn's rings are a quiet reminder of that truth beauty, whether cosmic or human, glimmers for a moment before it fades. And yet it is the fading that makes the present moment precious beyond measure. If the rings are Saturn's jewelry, then its North Pole is its most astonishing riddle, a geometric mystery no other world in the solar system possesses. A perfect hexagonal storm, each side thousands of kilometers long, rotating endlessly through time like a cosmic music box the universe forgot to close. No one knows exactly why it exists. Some scientists say it is the interference of atmospheric waves merging into a six-sided pattern, but even this remains an educated guess. What we do know is that the storm has persisted for over 30 years since Voyager 2 first saw it. It rotates with nearly constant speed. It maintains its hexagon shape despite the chaos of Saturn's atmosphere. It stands like a symbol, a reminder that the universe is not only beautiful, but governed by rules so strange they border on the sacred. Plotinus once wrote in the Enneads, "The stars are like letters inscribed on the sky." And at Saturn's North Pole, the universe has written an especially mysterious letter, a six-sided character no one can decipher, yet one that slows the breath of anyone who sees it. Leaving the hexagon behind, let us drift toward another world smaller, quieter, yet closer to us in spirit, Titan. Titan is the only moon in the solar system with an atmosphere thicker than Earth's, a place where you could walk on the surface without a pressure suit, only a mask against the brutal cold. The lakes of Titan are not water, they are liquid methane. The rain of Titan is not water. It is hydrocarbon rain, golden droplets falling upon a world untouched by Earth-like life. The sky of Titan glows soft orange. The temperature falls to a 1 degrees Celsius. Yet beneath that frozen shell, a subsurface ocean may lie warmed gently by tidal forces. Carl Sagan wrote in Pale Blue Dot, "On Titan, the chemistry of life is happening right now." He did not mean that Titan already has life, but that Titan is replaying the earliest chapters of Earth's story 4 billion years later. If Earth is an adult, Titan is an infant learning the alphabet of life for the very first time. NASA knows this too. That is why Dragonfly, a giant drone, is preparing to fly across Titan to listen for the first faint whispers of a world still writing the opening lines of its history. If Titan is a child, then Enceladus is a quiet artist, one who hides everything inside until the moment it can no longer hold it. From cracks on its icy surface, Enceladus launches towering plumes of water. Hundreds of kilometers into space, water, ice, methane, and most importantly, organic molecules. Cassini's data revealed that Enceladus' subsurface ocean has heat, water, organic chemistry, geological activity. In other words, everything required for life. Albert Camus wrote in The Myth of Sisyphus, "In the depth of winter, I finally learned that within me there lay an invincible summer." Enceladus is that idea made real, a world so cold it seems impossible for anything to stir. Yet beneath the ice lies an unyielding summer glowing quietly in the dark. Looking at the Saturn system, we see something rare, a perfect balance between beauty and profundity. The rings soft as silk yet fading. The hexagon storm, an unsolved equation. Titan, the sky of another universe. Enceladus, the ocean of hope. As Alan Watts wrote in The Wisdom of Insecurity, the more a thing tends to be permanent, the more it tends to be lifeless. Saturn's beauty lies in its impermanence. It is changing, disappearing, being reborn, breathing and trembling like every living thing. Now, having seen Saturn through the delicate lens of imagination, having watched its rings fall like snow, watched its hexagons spin like a meditative wheel, touched Titan and Enceladus, those worlds that may hold the first springtime of life. Let your body sink a little further into rest. Let your mind widen like space between the stars. And soon we will enter an even larger picture, a colossal web connecting all galaxies, the very skeleton of the universe woven from matter the human eye can never see. 7. The cosmic web, the skeleton of the universe. As we drift away from Saturn, that planet of soft mysteries where vanishing rings dissolve into darkness and geometric storms spin like ancient mandalas, your mind may still carry a quiet afterglow of awe. Titan with its dim amber sky, Enceladus with its towering plumes breathing from an ocean below, all of it reminding you that the universe is not only vast, but alive, delicate, rhythmic, and filled with hidden pulses. And then when you lift your gaze to the sky once more, you begin to sense something even greater. Something in which Saturn, for all its beauty, is only a single fleck of dust. The universe is not a scattered collection of objects. It is a network, a colossal tapestry woven from light, shadow, gas, and time. We call it the cosmic web Mongloy Vu Tru, a tapestry woven from darkness. The first strange truth is this: the cosmic web is not woven from the things we can see. It is woven from something invisible, something modern. Physics calls dark matter. We cannot see it. We cannot touch it. It emits no light, no warmth, no reflection. And yet it forms the skeleton of the cosmos. It is like the deepest part of ourselves, the memories, the emotions, the unseen patterns that shape the ways we live, love, fear, and hope. Carl Jung wrote in The Archetypes and the Collective Unconscious, "In all chaos, there is a cosmos. In all disorder, a secret order. Dark matter is that secret order. Unseen, but because of it, galaxies hold together. Galaxy clusters do not drift apart, and the universe weaves itself into filaments stretching across billions of light years. If you could see the universe from a far enough vantage point, far beyond any human scale, you would witness something almost unbelievable. Galaxies are not scattered randomly. They gather into filaments, vast threads of light, hundreds of millions of light years long. They resemble the blood vessels of the cosmos, connecting galaxy clusters, guiding the flow of matter and energy through space. And where the filaments intersect, we find superclusters, cosmic cities containing trillions of stars floating like luminous archipelagos in a vast dark ocean. One of the largest structures ever discovered is the Hercules Corona Borealis Great Wall, a galactic wall nearly 10 billion light years long. So immense that even if you traveled at the speed of light, you would spend nearly a third of the universe's entire lifetime just crossing it. There is a strange beauty in this scale, a beauty that makes us small, but not in a frightening way. Small in a way that opens the heart, as though a new space has quietly formed within your chest. Between those glowing filaments lie immense regions of darkness called voids, cosmic deserts. Imagine valleys so empty that light must travel hundreds of millions of years before meeting another star. And yet this emptiness also carries a peculiar beauty. It is like the quiet moments in a human life, moments of pause, of breath, of listening inward. Antoine de Saint-Exupéry wrote in Terre des Hommes, "What makes the desert beautiful is that somewhere it hides a well." The cosmic voids, the deserts of the universe, carry their own hidden mysteries as well. If the cosmic web is a grand tapestry woven over 13.8 billion years, then the James Webb Space Telescope JWST is the microscope allowing us to see the very first threads ever woven. When JWST observes galaxies at redshift 10, 11, 12, it is looking back to a time when the universe was only a few 100 million years old. Those galaxies are tiny, scorching, hot-rich, and primordial hydrogen undergoing ferocious star formation. They are like the first embers being blown into flame in the furnace of the young universe. When we see that light that has traveled 13 billion years to reach our eyes, we suddenly feel something uncanny. We are looking at our own past, because every atom in your body was forged in stars, like the ones shining in those ancient galaxies. Carl Sagan said in Cosmos, "We are a way for the universe to know itself." And the cosmic web is the body the universe is trying to understand through the small, fragile eyes of humankind. When you picture the cosmic web, its endless filaments, its radiant clusters, its silent voids and dark matter, flowing around it like a boundless sea, you may sense something deeper still. The universe resembles the vast brain of existence itself. Indeed, simulations comparing the cosmic web to the human brain reveal strange similarities, nodes of connection, expansive networks, dense hubs, and spacious gaps. Perhaps the cosmic web is not only the skeleton of the universe, it is also a mirror reflecting the structure of consciousness, a map of invisible connections living both within the cosmos and within the human mind. Rilke wrote in Letters to a Young Poet, Live the questions now, and the cosmic web is one of those questions. A question the universe whispers to us. Where do we come from? Where are we drifting? And what binds all lonely points of light across the deep darkness? Now, having seen the cosmic web as a glowing tapestry stretching gently across billions of light years, imagine one more thing. What happens when something powerful enough shakes that tapestry? What happens when space and time not only exist but vibrate like strings on a cosmic instrument? That is the story of black holes of collisions that bend space-time of gravitational waves rippling outward like the heartbeat of the universe. When you are ready, close your eyes for a moment, for we are about to hear the sound of the universe not with our ears, but with the quiet chamber of the heart. We will step into it as gently as stepping into a long and ancient dream. 8. Black holes, from near Earth to the dawn of the universe. As we drift away from the glowing threads of the cosmic web where galaxies hang like droplets on a vast celestial web where dark matter holds everything together with an invisible patient hand, perhaps you begin to sense something strange. Space, though infinite in its vastness, does not seem entirely silent. It has rhythm, it has structure, it has vibrations, faint distant, like echoes too soft for the ear to hear, yet clear enough for the heart to feel. And it is within those vibrations that we now step into our next story, a story about the entities that make space-time tremble black holes. Nietzsche once wrote in Beyond Good and Evil, "If you gaze long into an abyss, the abyss also gazes into you." Nowhere is that more true than when we look into a black hole. From afar, a black hole appears like a dark blot of ink on the bright parchment of the universe. But the truth is far more delicate and profound. A black hole is not emptiness. It is a place where matter becomes so dense that even light cannot escape. A place where space is curved, time slows, and the familiar laws of physics dissolve like sand in water. Einstein never saw a black hole with his eyes, but his equations saw them clearly. Black holes are proof that the universe is not only vast and beautiful, but also an artist, one capable of creating phenomena that hover at the edge of contradiction. For decades, scientists believed there were only two kinds of black holes: stellar black holes, a few dozen solar masses, supermassive black holes, millions to billions of solar masses with nothing in between, like a world where only children and the elderly existed but no youth in the middle. Until recently, signals from dense star clusters revealed the existence of intermediate mass black holes, those with about 100 to 100,000 solar masses. They are like missing children in the cosmic family tree. No one knows how they were born, how they grew, or why they exist at all. They live at the fragile boundary between worlds, like those transition moments in life that are neither beginnings nor endings, but mysterious in between spaces with no name. And here is something surprising. Not all black holes lie billions of light years away. One of them is only about 1,060 light years from us, a tiny distance in astronomical terms. Its name is Gaia BH1. Gaia BH1 is so silent, so perfectly hidden, that it was discovered only through the gravitational wobble it induced on a companion star. It does not consume matter. It emits no X-rays. It produces no glow, no roar, no flare. It simply is a quiet, self-contained darkness, perfectly at ease with its own invisibility. It brings to mind a line from Rilke in Letters to a Young Poet: "Let everything happen to you, beauty and terror. Just keep going. No feeling is final." Gaia BH1 is that blend of beauty and terror, an entity both near and distant, harmless yet astonishing. And not all black holes remain anchored in place. Some are kicked out of their galaxies by supernova explosions or flung outward by chaotic orbital interactions. They drift through the void like orphaned shadows, no light, no sound, no companion, no home. If the cosmic web is the network that binds galaxies together, these wandering black holes are the wanderers who break free from every connection, moving into emptiness with perfect silence. Yet in their solitude, they teach us something deeply human, that some journeys need no destination, no illumination, no audience, and yet they exist with their own quiet dignity. If the cosmic web is the structure, then gravitational waves are the music of the universe, and black holes are the instruments that play it. When two black holes approach one another, their orbits spiral inward like a slow celestial waltz. They spin and spin faster until the fabric of space-time stretches around them like drawn silk. And then they merge. That moment releases gravitational waves, ripples in space-time, traveling for billions of light years. LIGO detected them for the first time in 2015, a discovery that silenced the entire world. Einstein described space-time as a flexible fabric, but even he may never have imagined that one day we would hear its vibrations. Each black hole collision creates a unique tone, a signature marked by mass, spin, and distance. If translated into sound, these tones resemble deep resonant knocks from a colossal cosmic instrument. Nietzsche wrote in Thus Spoke Zarathustra, and those who were seen dancing were thought to be insane by those who could not hear the music. The universe has been dancing to its own music for eons. Only now are we learning to hear it. And if you immerse yourself in this idea, you may sense something quietly beautiful. The cosmic web is the body of the universe. Black holes are its slow-beating hearts. Gravitational waves are the rhythm those hearts release, as if the universe itself is breathing, moving, alive. In Cosmos, Sagan wrote, "Somewhere something incredible is waiting to be known." And black holes, with all their darkness and all their light, whisper that truth every day. Now, having listened to the song of space-time, having touched the nearby shadows and the deep cosmic ones, let your body relax a little more. Let your breath fall into the soft rhythm of the universe. We are no longer speaking of black holes or cosmic filaments, but of the very thing we have always searched for life. Where in the endlessness could life find a home? What makes a world capable of blooming into life? And among the billions of stars, how many planets truly resemble Earth 9? External habitability, exoplanets and the conditions that give rise to life. As the gentle hum of gravitational waves from the previous chapter fades into the dark, as the deep resonance of two merging black holes still lingers like the last breath of the cosmos, perhaps you realize something. Though we have listened to the heartbeat of space-time, seen shadows that swallow light, and walk through regions where the universe bends like stretched fabric, a quieter, more human question still hangs in the mind. Amid all this vastness, is there a place for life? Is there a world besides Earth that could become home? Across billions of galaxies and trillions of stars, how many planets resemble Earth? How many worlds allow water to flow atmospheres to cradle surfaces and life, whether fragile or fierce, to bloom in silence? Tonight our journey brings us here to the realm of exoplanets, the worlds beyond our sun, and the possibility of life outside Earth. A chapter of hope, a chapter of small lights flickering in infinite night. When we speak of life, we often begin with one simple requirement: liquid water. Water is the foundation of all biology on Earth, a solvent for chemistry, a cradle for molecules, a soft architect of every living form. For water to remain liquid, a planet must orbit its star at a very particular distance, the habitable zone, or the Goldilocks zone. The name comes from the old tale, not too hot, not too cold, just right. But in the universe, just right is unbelievably delicate. A planet drifting only 5–10% closer to its star may become another scorched Venus. Drifting 5–10% farther may become a frozen Mars. We tiny temporary beings were born in such a fragile equilibrium. And now, with science as our lantern, we wander the cosmos seeking other places bathed in similar gentleness. Seneca once wrote in Natural Questions, "We are waves of the same sea leaves, of the same tree flowers, of the same garden." The Goldilocks zone reminds us that even amid the universe's turbulence, there are pockets of quiet where life can take root. If you look toward the southern sky on a perfectly still night, somewhere among those twinkling lights lies Proxima Centauri, the closest star to our sun. And circling it, there is a world whispered about in scientific circles for years, Proxima Centauri b. This planet lies within its star's habitable zone, is nearly Earth-sized, may hold liquid water, and sits only 4.2 light-years away. 4.2 light-years in cosmic terms, a neighbor. To humanity, it is like a dream just behind a thin curtain, close enough to imagine, too far to touch for now. What makes Proxima b extraordinary is not merely its similarity to Earth, but the question it inspires. If life exists, there might it ever lift its gaze toward our sun. If life is the story the universe tells, then perhaps Proxima b lies only a page away from ours. When you look at the stars, you see beauty. Science sees language, a letter written in light. We detect exoplanets through two main methods. One, transit method, observing a shadow across starlight. When a planet passes in front of its star, the star's brightness dips ever so slightly, a few thousandths or even millionths. Tiny signals yet profound enough to whisper, there is a world passing by. It is like standing at your window at night and seeing the shadow of a small bird glide past a street lamp. No shape, no color, no voice, but you know life has moved through the frame. 2. Spectroscopy, reading the universe's color signature. When starlight passes through a planet's atmosphere, it carries the atmosphere's chemical fingerprints. CO2, O2, methane, water, vapor. Each appears as a faint line in the spectrum, pencil strokes drawn in light. Spectroscopy reveals whether a planet has an atmosphere, how thick it is, whether it can hold water, and whether life might dwell there. William Blake wrote in Auguries of Innocence, "To see a world in a grain of sand, spectroscopy allows us to see a world in a single ray of light. Yet even if a planet lies within the Goldilocks zone without an atmosphere, it is still dead. An atmosphere retains heat shields against radiation, keeps water from escaping, and enables the chemical cycles of life. On Earth, the atmosphere is the breath of the planet. On exoplanets, it serves the same role. But an atmosphere survives only if a planet has enough mass to hold its gases' magnetic field to protect it from stellar winds. Proxima b, for instance, may have water, but it orbits dangerously close to a temperamental red dwarf whose stellar flares could strip its atmosphere unless a powerful magnetic field stands guard. And so, in the search for life, we ask not only does this planet have water, but also can this planet protect itself? A deeply human question. To live, one needs not only a good environment, but the strength to endure it. Exoplanets are not merely spheres of rock orbiting distant stars. They are doorways, openings into the possibility that life is not a single accident of Earth. Alan Watts wrote in the book, "You are an aperture through which the universe is looking at itself." And when we look outward, when we search for life elsewhere, perhaps the universe is also trying to understand itself through our searching eyes. Exoplanets and the quest to find life upon them are ultimately a journey to answer the oldest question humanity has ever carried. Is anyone out there? Perhaps the answer will come from an unusual methane spectrum, or from a shadow too regular to be geological, or from a world with a thick atmosphere and flowing water. Or perhaps it will come from somewhere even more distant, a place we have yet to imagine. 10. Assembly theory. The mathematical formula that attempts to decode life. As we drift away from the distant planets, those worlds resting in their Goldilocks zones, holding liquid water like a secret, and guarding the possibility of life within their fragile atmospheres, perhaps a soft question still lingers in your mind. What is life truly? What makes a world habitable? What transforms an inorganic molecule into a link in a DNA chain, then into a cell, then into a creature capable of dreaming and wondering? And beneath all those questions, another rises quietly from the depths of thought. Is there a precise mathematical way to recognize life when we find it? This is where assembly theory enters a new, bold, controversial, and strangely elegant idea, a theory that attempts to measure life by its complexity. Physicist and philosopher David Deutsch wrote in The Beginning of Infinity Explanations Are the Currency of Science. Assembly theory is one such explanation, an attempt to answer one of the oldest questions ever asked. What does it mean for something to be alive? Before we enter the theory, remember this. In the previous chapter, we looked outward toward Proxima b, toward distant worlds, where water might flow and atmospheres might cradle life. But now we turn inward toward the essence of life itself, toward the mathematical rules hidden inside every molecule, toward the way the universe assembles structures capable of self-replication, self-maintenance, and self-storytelling. Our journey shifts from the external to the internal, from cosmology to biology, from habitable worlds to the deepest architecture of life. Let your mind soften as though standing at the threshold between two realms, one searching for life far away and one trying to understand life at the level of atoms. Assembly theory proposes that every object, every molecule, every structure in the universe possesses a certain degree of complexity. And that complexity can be measured by the assembly index, the number of steps required to build that structure from the simplest building blocks. For example, a small simple molecule to low assembly index, a long branched protein to high assembly index. DNA with its immense length and organization to an extraordinarily high index. The theory suggests that life emerges only when complexity surpasses a certain threshold, a threshold too improbable to be achieved by random chance alone. Life in this view is not merely chemistry, but the accumulation of complexity over time. As Aristotle wrote in Metaphysics, the whole is more than the sum of its parts. Assembly theory treats this statement as the mathematical foundation of biology. A living organism is not just a collection of molecules, it is complexity woven into coherence. If thermodynamics tells us that everything tends toward disorder, then life is one of the rare processes that persistently pushes the other way. Entropy rises, yet life builds order. Life organizes complexity against the natural current. Assembly theory argues that life is the ability to continuously outpace entropy using energy not by denying disorder, but by dancing with it, shaping it into structure. Carlo Rovelli wrote in 7 Brief Lessons on Physics, "The world is not a collection of things, it is a network of events." Life, under assembly theory, is precisely this, a chain of events that overcome entropy, a sequence of assembly steps that create organization the universe does not produce by accident. One of the theory's most poetic ideas is chemical memory. A complex molecule is not just a structure, it is a memory of the steps taken to build it, a record of its assembly journey. RNA proteins, DNA. All of them hold the history of their own creation. They are the universe's diary at the molecular scale, documenting the path from primordial chaos to biological order. In this way, life does not merely exist, it remembers. And as life evolves, it becomes the universe writing newer and deeper chapters of itself in 4-letter alphabets, A-T-C-G. Nietzsche wrote in Thus Spoke Zarathustra, "That which does not kill us makes us stronger." Assembly theory might say, every assembly step that survives destruction becomes memory, and memory strengthens life. But the boldest aspect of assembly theory is not its definition of life, it is its proposal for how to search for life beyond Earth. Rather than look for water, oxygen, methane, or atmospheres, the theory suggests, measure molecular complexity. If the assembly index of a detected molecule is high, then life, or at least the precursor to life, may be present. For example, methane, a simple molecule to low index to easily formed without life. A protein of 200 amino acids to extremely high index to unlikely to form randomly. Thus, if we detect high-index molecules in the atmosphere of an exoplanet, they might be powerful biosignatures. Just as Carl Sagan wrote in Cosmos, extraordinary claims require extraordinary evidence. Assembly theory seeks that extraordinary evidence not through intuition, but through mathematics. Naturally, the theory receives criticism. Some say it oversimplifies life. Others argue it neglects environmental and biochemical context. Some believe the assembly index does not truly reflect biological complexity, and that is good. Science thrives on debate, on challenges to old assumptions, on new myths being tested. Karl Popper wrote in Conjectures and Refutations, "Science must begin with myths and with the criticism of myths." Assembly theory is one such emerging myth, a new story science is attempting to tell. Whether it stands or falls, it invites us to think more deeply about what life truly is. Now, as you listen to the story of how the universe assembles life from its smallest pieces, as your mind drifts along the slow currents of entropy and structure, as you feel that life is not merely biology, but a mathematical poem woven into existence, let your breath slow. Let your body sink deeper into stillness, for the next chapter will carry you outward beyond the boundaries of the solar system, to Pluto, to the Kuiper Belt, to realms cold yet filled with story. Pluto, the Kuiper Belt, and the mysterious history of the solar system's edge. And I will guide you onward through frozen landscapes that shimmer like distant dreams of the universe. As you drift out of the reflections on complexity, entropy, and the way the universe assembles life, molecule by molecule, perhaps a strange sensation begins to rise within you that whether we speak of molecules or planets, of DNA or galaxies, everything carries a history. A past not written in words, but in structure, in scars, in the shapes that survive to this moment. And that very feeling leads you into this next chapter. A chapter not about life, but about memory. The forgotten memory of our own solar system. Memories dusted with frost, resting on worlds so distant that sunlight touches them only as a faint whisper. Let your mind glide gently beyond Neptune's orbit, like a small leaf drifting toward deeper shadow, for we are entering the realm of Pluto, the Kuiper Belt, and the hidden history at the solar system's edge. Pluto, the small world with a heart of ice. When New Horizons flew past Pluto in 2015, humanity paused just for a moment, not because of scientific data, but because of an image that stirred something deeply human. Sputnik Planitia, a vast frozen heart carved across Pluto's face. A nitrogen ice plain, soft as cream, yet stretching thousands of kilometers, reflecting distant sunlight with a quiet, fragile glow, as though Pluto, wandering billions of years in cold solitude, had been carrying a heart all along, waiting to be seen. Nietzsche wrote in Human All Too Human, "Invisible threads are the strongest ties," and Pluto's icy heart became one such invisible thread, binding a forgotten dwarf planet to human emotion. A world demoted, overlooked, almost dismissed, yet still holding a symbol of tenderness, as if whispering, even in darkness, one may still carry a heart. The pale blue haze, the faint breath of a faraway world. As New Horizons drew near, Pluto revealed something even more astonishing, a thin, ethereal blue atmosphere. The blue was not Pluto's own light, but sunlight scattered by tiny haze particles, a delicate glow around a world too cold to sustain life, yet warm enough to stir awe. A paradox of beauty, too thin to nurture life, yet enough to create a halo of blue, turning Pluto into a frozen crystal wrapped in shimmering light. It feels like emotions too fragile to touch, yet strong enough to make us stop, look more deeply, and breathe more slowly. Rilke wrote in the Book of Hours, "Let everything happen to you, beauty and terror. Just keep going. No feeling is final." Pluto embodies this truth: beauty and loneliness intertwined, no emotion, even the coldest, ever final. Charon, the companion that never leaves. Pluto is not alone. It has a partner, Charon, a moon so large relative to Pluto that the center of gravity between them lies in empty space, causing both worlds to orbit each other like dancers locked in an eternal waltz. They are tidally locked. Pluto always shows one face to Charon, and Charon always faces Pluto. No turning away, no drifting apart. If you stood on Pluto, you would see Charon fixed in the sky, never rising, never setting. A quiet guardian in the dark. There is something deeply human in this bond, a reminder that even the most forgotten worlds may still have a companion. Jung wrote in Memories, Dreams, Reflections, "In each of us there is another whom we do not know." Pluto and Charon are like two halves of one soul, incomplete alone, yet telling a complete story together. The Kuiper Belt, a frozen archive of solar history. As we drift beyond Pluto, light dims, shadow deepens, and a profound silence settles. This is the Kuiper Belt, the frontier of the solar system, where thousands of icy bodies drift like fragments of ancient memory. If the asteroid belt is the rubble left over from building rocky planets, the Kuiper Belt is a vault of untouched materials preserved since the birth of the solar system. A graveyard, a library, a frozen museum, and a mirror reflecting how our cosmic home formed, evolved, and learned to cradle life. New Horizons, the eye that opened a new universe. Before New Horizons, Pluto was nothing more than a blurry dot in our telescopes. But as the small spacecraft crossed 5 billion kilometers of space, it peeled open an entire world. Mountains of solid ice reaching 3-kilometer high, frozen nitrogen glaciers deep. Fractures, rippling plains, landscapes shaped like a heart. New Horizons did not simply photograph Pluto. It photographed humanity's humility, the awe of seeing what had never been seen. Carl Sagan wrote in Pale Blue Dot, "Exploration is in our nature. We began as wanderers, and we are wanderers still." Pluto and the Kuiper Belt remind us we wander not only to find new homes, but to understand our origins. The solar system's strange youth, a story still unfolding. Data from Pluto and the Kuiper Belt unveils something astonishing. The early solar system may have been far more chaotic than we imagined. Some models suggest Jupiter and Saturn migrated in their youth, dragging icy bodies outward, flinging others inward. The wild orbits of Kuiper Belt objects tilted, stretched, twisted, look like scattered memories of that turbulent adolescence. Pluto itself bears the imprint of this chaos, a small world with a heart tilted on an odd orbit, carrying the breath of a story unlike any other. Confucius once wrote in the Analects, "The hardest thing of all is to find a black cat in a dark room, especially if there is no cat." The Kuiper Belt is that dark room, and we are searching for a cat that might never have been there. But the searching itself is what teaches us how to see in darkness. Now, as you have journeyed across icy Pluto, touched its frozen heart, floated past Charon, and watched two worlds dance in silence, and felt the Kuiper Belt as a museum of the solar system's childhood, let your breath deepen. Let your body soften like snow under dim light. For the next chapter, the final chapter will bring you back from these far-flung frozen realms into a story that belongs intimately to humanity. The future of our species, generation ships, and interstellar travel. A chapter of hope. A chapter of leaving and returning. A chapter about how we, despite our smallness, still dare to dream of the stars. When you are ready, I will guide you along the last stretch of tonight's journey. 12. The future of humanity, generation ships, and interstellar travel as we drift away from the Kuiper Belt, that frozen boundary where Pluto and Charon dance together in the dark, where the ancient rubble of the solar system still floats like unopened memories. Perhaps something different is awakening inside you. Pluto was the story of our solar system's past. The Kuiper Belt was the archive of events written more than 4 billion years ago. But when we turn our backs to that ancient memory, a new question rises, gentle as wind, deep as the night sky. If this is where we come from, then where do we go next? There is something profoundly human and profoundly cosmic in that question. A need older than civilization itself, the need to keep moving forward. And so the final chapter of tonight's journey unfolds a chapter not about distant worlds, but about us and the longest voyage we can imagine, interstellar travel, generation ships, and the future of humanity when we finally step away from Earth. Earth feels eternal, but it is not. It is easy to believe that Earth is forever. But when we look through the lens of cosmic history, a gentle yet stern truth appears. No place in the universe is completely safe. Nothing remains unchanged. Climate shifts. The sun slowly brightens. Asteroids pass by with the quiet threat of erasing worlds just as they have before. Humanity does not leave Earth to escape. We leave because it is our evolutionary instinct to continue to expand, to seek new horizons. As Tennyson wrote in Ulysses, to strive to seek to find and not to yield. To leave is not to abandon, it is to refuse surrender to the finiteness of our birthplace. The stars are too far, and so we imagine ships that outlive us. Even Proxima Centauri, our nearest star, is 4.2 light-years away. With today's spacecraft, the journey would take tens of thousands of years, and so humanity imagines something both humble and astonishing. Generation ships, vast vessels, whole floating cities where children are born, adults live and work, the elderly grow old and depart while the ship continues forward. A journey that surpasses a lifetime, but not a lineage. Can you picture it? A glowing hydroponic field under artificial light. Children playing in classrooms where windows do not show skies. Elders telling stories of Earth as though speaking of a distant myth. And outside the hull, only darkness and stars fixed like threads of crystal. Nietzsche said, in Thus Spoke Zarathustra, "One must still have chaos in oneself to be able to give birth to a dancing star." A generation ship is exactly that, the chaos within humanity, struggling to give birth to a new star, a future beyond Earth. The engines that could carry us across the interstellar sea. To send such a ship, we must transcend the limits of today's physics. 1. Ion engines, slow but patient. A thin mist of plasma ejected at incredible speed produces a tiny but constant push. Year after year, the ship accelerates to velocities chemical rockets could never reach. 2. Fusion engines, using the power of stars. Nuclear fusion, the process lighting the sun, could drive engines of unmatched efficiency. A spoonful of deuterium from seawater could power an entire ship. 3. Antimatter engines. The almost mythical option matter meets antimatter to total conversion of mass into energy. If mastered, it would shrink interstellar distance into something almost humanly reachable. 4. Light sail ships pushed by light itself. A thin reflective sheet pushed by Earth-based lasers. Light, weightless, yet possessing momentum, propels the craft as wind propels a sailboat across an ocean. These technologies reveal something beautiful. Humanity does not merely dream of the sky. We wish to touch it. Time dilation. When time stops being the same for everyone, Einstein's relativity tells us time slows down for objects moving near the speed of light. On the ship, 5 years pass. On Earth, 50 years. Interstellar travel becomes not just a journey across space, but a journey through time. You may leave young and return to find everyone changed. Or you may never return, and your descendants may come back in your place. Heidegger reminded us in Being and Time, we are time. When we leave Earth, we carry our time with us, stepping into the universe's time. The human challenges beyond technology. A generation ship is not only a technical problem. It is a question of society, identity, purpose, mental and emotional resilience. Children born on board will never see a true sky. They will never feel real sunlight on their skin, never smell the scent of Earth after rain. They must be taught not just mathematics, physics, biology, but meaning. They are inheritors of a journey they did not choose to begin. Kant wrote in Critique of Pure Reason, reason is the faculty of principles. A generation ship must be built not only on engineering, but on ethical and spiritual principles. Or a tiny civilization drifting in the void could collapse from fractures within its own heart. A miniature Earth sailing through the stars. To survive for centuries, the ship must have rotating sections to simulate gravity, hydroponic agriculture, closed-loop recycling systems for air and water, and perhaps even a small forest to stabilize atmosphere and soothe the human mind. A small Earth gliding through a sea of stars. There is something tender in that idea that even when we leave home, we carry its image with us. A patch of green, a pool of water, and the quiet dream of a blue world. The final breath of the journey. Now, as the last chapter unfolds, perhaps you feel something quietly luminous inside you. Human beings, though small, carry dreams vast enough to outgrow Earth. From the first molecules that defied entropy to worlds that hold water to Pluto with its icy heart to ships that may someday glide faster than light itself, all of it whispers a single truth. We are creatures of motion, of longing, of unfinished stories. Carl Sagan wrote in Cosmos, we are wanderers. We have always been wanderers. And perhaps on some distant future night when a generation ship silently leaves Earth's orbit, you will feel what you feel now, that we do not leave to escape. We leave to continue our story in a universe vast and gentle and waiting. Take a deep breath. Let your mind quiet. And if your eyes wish to close, let them close slowly. Because this journey, like life itself, never truly ends. It simply continues drifting soft as a star gliding across the night. And now, as our long journey comes to a close, as we step out of the 12 chapters of the universe, from the earliest dimensions of reality to the delicate strands of the cosmic web, to the hexagonal storms turning endlessly on Saturn to the frozen heart of Pluto, and the generation ships preparing to leave their cradle, perhaps you can feel something very strange happening. The universe is no longer out there. It is unfolding within your very breath. For every planet, every star, every particle of light is merely a grand metaphor for the small, quiet things that unfold inside us. The expansion of space, the black holes that swallow light, the hidden oceans waiting to be discovered. All of them mirror something in the human soul. We look into the universe to understand ourselves. And along the way, we realize that even though the cosmos is vast beyond comprehension, even though the stars are too distant to touch, even though our interstellar future is draped in mystery, in this moment, the moment you are listening, everything is close. Close as a heartbeat. Close as a breath. Rilke once wrote, "You must give birth to your own star." And perhaps the gentle light drifting through your mind right now is that star, a star only you can bring into being. So let your shoulders soften. Let your mind loosen like stars gliding past one another in silence. Let the thoughts of the long day fall away like cosmic dust returning to the dark. There is nothing left to hold, nowhere you need to go, no more answers you need to chase. The universe is vast, but tonight you only need one thing: to rest, to breathe, and to drift into sleep in the quiet arms of stillness. May your night be deep, gentle, as though the universe itself were wrapping around you and whispering, "See you again in the dream between the stars."